All right, how's it going today?
Good.
So I'm done taking attendance, which is unrelated to some suggestions on Discord this weekend that I should stop taking attendance because I had already decided to do this. But hopefully people keep coming to every class. But I will leave it up to you to decide for yourselves based on your schedules and whatever. Alright, so a bunch of things I want to talk about today. I want to talk about ODPs because we have a batch of new ODPs for this week. I want to talk about programming assignment 2, the stick program, and I want to talk about a rubric I posted for programming assignment 3. And then I want to start talking about string processing, but I'm going to do that all in the reverse order, I think. Sorry? Midterm is on Friday. So closed book, 4 pages of notes, double-sided, basically on what we've been doing so far. So you can expect some multiple choice, fill in the blank short answer, and you can expect some programming questions where you'll be writing pieces of code either in Bash or in C. Make sense? Alright, and it should be like a 50-minute midterm.
How will you know if we accidentally put an extra space?
Well, I know if you accidentally put an extra space. I will not, but I am not as picky as Bash is. Unlike Bash, I can adapt. Alright, other questions? Alright, so let me talk about PA2 first. So I graded your stick playing game in C. Again, really nice work with PA2. A lot of people nailed it 100%. A lot of people lost a few points for what I'm going to call silly things. Where the code itself was basically correct, it was playing the game correctly, but it wasn't doing something exactly like the assignment asked you to, like processing errors a certain way or that kind of thing. That's an issue with sort of translating from here's what I'm supposed to do to a description of what you're supposed to do to your understanding of what it's supposed to do. But the gameplay and picking sticks and the CPU algorithm, that kind of stuff, that was pretty much perfect in most cases, which is excellent. Most people used functions, which is really excellent too. And again, if using separate functions for things confuses things, don't do it. But if it makes sense to make a print stick function because I have to do the same set of code 2 or 3 times in my program, throw it in a function, and I saw a lot of that. So that's really good. So yeah, I was definitely happy with what I saw. If you did not finish PA2, so some people did not get their code to work, or they had syntax errors or things like that. In a lot of those cases, they also told me that they started too late. They underestimated what this would take, and they started a few days before it was due. And that's part of what you're figuring out in your classes here at Clark and beyond, is sort of time management and expectations and things like that. So if that was the case, if you ran out of time for this one, hopefully that means the next one you start sooner or allocate more time or whatever. And I sometimes have students who they're taking computer science, they're taking physics, and they've done the calculus and decided I can live with a C in computer science. I really need to pass physics, and so that's going to get 85% of my time, and they put in enough effort in, say, this course to pass, but nothing more. And that's part of what you're trying to figure out, is how do you get everything done that you need to do. I mean, that's a life lesson, because you never have enough time in life. So whatever you've got going, wherever you are, you're always going to be juggling priorities. And so that's good learning, even if it means that I know I could have done this program if I had more time, but I had to spend time on this instead. That's okay. But always make sure you turn something in, right? Because if there's absolutely nothing, it's just a 0. There's no wiggle room there. Which brings us to homework 2, which was supposed to be a way to make sure that you get PA3 turned in on time because you're making a Git repository. And I looked Sunday and 16 people had done the homework, and I looked this morning and 19 people had done the homework. So about 2/3 of the class has not created a Git repo for the high-low program. So please, please, please do that sooner rather than later. But it's due tomorrow morning. So. All right. So stick picking game. So let me show you some code that I put together to do PA2. So this is just an example. Comment block in the beginning, okay? You're going to lose points on PA3 if that's not there. I didn't explicitly say in PA2 that you had to have your name in the code. Always put your name in your code, okay? It's really important. It's a work of authorship. So put your name in there, put in the course, put in the date, and put in a sentence or two telling me what this code is. Right? It doesn't have to be fancy. Don't copy and paste the assignment. Just what is it? Right? What does this program do? And throw that in the beginning. Unless it's a bash script, put the /bin/bash first, and then this. So include standard I/O. I put my prototypes at the top, and I just sort of put little comments next to them to say what they do. But you know, that's up to you. It's useful. Before you start reading the rest of the code to know, okay, what does get move do? What does CPU move do? What do they take, and so on. If I'm writing a really big program, sometimes I take this and my function prototypes, I'll just put them in a separate window. So I can refer to them. So as I'm writing my code, if I want to print the sticks, I can say, okay, what do I pass to print sticks? And so on and so forth. So you got to do main argc argv because you needed to process command line arguments. And if your code just said, you know, void main paren, you're not going to be able to process when someone says stick 25, right? So there's my welcome message. So I decided to do this with a bunch of functions because most people did a bunch of functions. So I call in a Nit routine, I pass it the argc and argv, and this is going to basically process the command line arguments. If they were specified incorrectly, it's going to print out an error message and return a 0, which means there's a problem. If it finds a command line argument and it's not an integer, it's going to print an error message and return a 0. If it finds an integer smaller than 10, it's going to print an error message and return a 0. If it doesn't find a command line argument, it's going to ask you how many sticks you want and do the same thing. Read in your input. If there's an error, it'll print a message and return a 0. If everything works out fine, it's going to return however many sticks you want to play with. So in my main program, it's all just one line, just a init, pass it the arguments, and have it return a value which I call numsticks. And if that's equal to 0, I know something went wrong, I'm done, I just exit. This was something that a lot of people missed, by the way, and I did not take off points for it because it must have been confusing because about half the assignments didn't do this. But if there was any error in the initial number of sticks, you were supposed to exit immediately after printing a message. A lot of people, if you said sticks 5, printed a message saying number must be at least 10, and then asked how many sticks you wanted to play with instead of exiting. So I didn't take off for things like that. But any error in there, init returns 0, and we just exit. Otherwise, print the initial pile of sticks. And then this was really an infinite loop, but I set a playing variable equal to 1 in case I wanted to do something more clever, like set playing to 0 when we're done. So here's the whole while loop. It's a user move and a CPU move. So what's the user move involve? Get move asks the user how many sticks they want to take, and it returns that integer value. So I subtract that from numsticks. And then if numsticks is less than 0, I print out a message saying you won, and I exit. right? Just return from main. Otherwise, I print out the pile of sticks right here. And then it's the CPU's turn, so I call CPU move. It has to know how many sticks we have. So this returns the number of sticks the CPU takes. Right, I store that in CPU takes. I print that out. This is just a Kernighan and Ritchie trick. Computer takes %d, that variable stick, and instead of saying stick or sticks, I say stick with a %s. And that's either an empty string if it's taking one stick, or it's an s if it's taking something other than one. So it says 0 sticks, 1 stick, 2 sticks, and so on. And then I subtract that from the number of sticks, so now num sticks is the number of sticks left. If that's equal to 0, print out a message saying the computer won and exit. Otherwise, print the stick pile, and then just go back to the top of the while loop. So that's the whole gameplay, and it fits on one screen, which means it's fairly easy when you're debugging it to sort of follow what's going on. It fits on one screen because all the hard work is done in these other functions. Right, so that's one of the ideas of using these functions. And it's a single while loop with a few ifs. And I'm never going to exit that while loop through the bottom, right, because my playing flag's always 1. And while playing, so C has this thing, if you say if some expression, or while some expression, this is true if expression is not 0, false if it's exactly 0. That's just a thing that standard C does. Java does not do this. But in C, if you have some kind of numeric value inside your conditional, if that value turns out to be equal to 0, that condition is considered to be false. If it's non-zero, it's true. So you can get away with kind of the shortcut. Instead of saying while playing equals 1, you can just say while playing. And it's not a Boolean, but it kind of acts like it. And then there's just a series of functions. So print sticks is pretty straightforward. We've done that in a few different versions. It's a for loop, prints out the pipes, and then prints out the number of sticks in parentheses. I got a few fancier stick pictures from people, which is really cool. One person printed out like matches, like a few lines, and then a little thing on top for the flame. That was cool. Okay, ask the user how many sticks they want to take. So this is a little bit more of a process. I asked them how many sticks you want to take, use fgets to read the input, and then do the scanf trick. Okay, this is a good answer they gave me if the following is true. The return value is exactly 1, which means there was an integer and nothing else, and the integer is between 1 and 3. Okay, the complement of that, use De Morgan, complement each thing and change the ands to or. So if the return value is not 1, or the number is less than 1, or the number is bigger than 3, then that's not a valid response. Right? Either return value is different from 1, they didn't just type one integer, or the number is out of range. In any of those cases, we have to ask them again. So I asked them how many sticks do you want to take, and I remind them 1, 2, or 3, and then I repeat the fgets and the scanf and go back to the while loop. So this will just keep spinning back and forth until they finally put something in and it scans and the return value is 1 and the number is between 1 and 3. Once they've done that, then I just return the number they put in, which is how many sticks they want to take. So that's the return value from the function. The CPU move is a little easier because the CPU doesn't make as many mistakes. So take the number of sticks mod 4. If that's 0, then they should take 1 stick, and then just return however many they want to take. And then the command line parser is a little bit of work. So we take an argc argv like main, and first possibility is they put in too many arguments. So argc can be 1, 2, or bigger than 2, right? Okay, it can never be 0. That's just the way that it works. If it's 1, ask a user how many sticks they want to play with. If it's 2, arg bracket 1 is the number of sticks. If it's bigger than 2, that's an error. So an easy way to slice the code is to just look at argc. If it's bigger than 2, that's an error. I'm going to check that first, because I can just return. I don't have to nest my parentheses or anything. If argc is equal to 2, then they gave us a command line argument, so we go ahead and we parse it to make sure it's legal. So do the scanf, look for extra stuff, make sure scanf returns 1 and that the number is bigger than or equal to 10. And if it is, then return the number. Anything else, return a 0. 0 is our error flag. Right, when we call this function, if we get a 0 back, we'll say goodbye. So if there's exactly one argument, they've got one shot here, which is that it's a correct value, in which case we return that value. Otherwise, put in an error, return 0. And then if they did not, if argc is equal to 1, that's the only other option, then we have to ask them how many sticks. We get the response from them in temp, and then we do exactly the same code that we did up there. So scan it, make sure it returned to 1, make sure the number is bigger than or equal to 10. If it is, return that number. Otherwise, give them an error if something went wrong. So that's similar to what most people did as far as breaking things up into functions. There's a lot of different ways you could do this. Another possibility, which some people did, is to take each of these functions and put them into a separate file, and you end up with a CPU move.c, you end up with an init.c, and so on. Then you compile all those together to make your executable, and we'll be moving towards that when we get to PA4. We'll be talking about ways to do that. So questions about PA2? So if you did not get PA2 to work to your satisfaction, and it wasn't just that, this is good enough, I have other things that take priority over this. If you're not sure how to get PA2 to work, make sure you talk to me really soon, okay? And let's figure it out, because when I look at people's code where there's compile problems or where it's seg faulting or things like that, I can see in most cases what you're trying to do, and it's just that the computer can't see it, right? And how do you get the computer to see what you're trying to do? Well, you have to use this language we call C. And it's just a very particular language, and you get one piece of it wrong and the computer thinks you're saying something different, right? And that part we can definitely figure out and fix easily, right? That's the easier of the challenges involved in making something like this work. The harder part is understanding the algorithm. And it looks like most people understood the algorithm and were trying to tell the computer, do this, do this, do this, where these were the right things to do. And it's just a problem in translating that into C. So definitely catch me in office hours or somewhere, and let's go through your code and figure out those things. Because if you fix a few of those things to make this work, chances are that'll work for the rest of your C programming as well. Make sense? All right. So questions about what programming assignment 3 should do, the high-low game. We talked about it Friday. We played through it a few times. All right, so I posted a grading rubric for PA3. So let me run through this and make sure everybody knows this. And this is what I'm going to use to figure out your grade. So you can treat this like a checklist, right? Go through it and check each of these things and make sure that you've done it. And if you don't know what these things mean, ask about it ahead of time, right? Okay, so first thing, if your HL repository does not exist and or is not readable by me as of the due date, you get a 0. Okay, nobody should have that happen, right? Because by tomorrow morning at 8, everybody should have their HL repository and I should be set up as a reporter. And if you get 100% on homework 2, you're good to go, as long as you don't change something, right? Just keep pushing things over to the HL repository. If you don't get 100% on homework 2, then you're in danger that you're going to get a 0% on PA3. Okay, so talk to me and let's figure it out this week. Okay, so HL's got to be readable by me. If there's some major mishap with your script, like it's trying to guess my number or it's doing a stick picking game or something like that, right? That's potentially a 0%. So make sure that you've got the right script in there and so on. If it's not named HL, 10 points. If it's not runnable, 10 points. If you don't have the shebang in the beginning, 5 points. If it does not have your full name as it appears in Canvas, it doesn't have to be exactly what's in Canvas, but you know, no initials. If it doesn't have your full name, 20 points. If it does not have that comment block describing the program and the date and so on, that's 10 points. If it doesn't print a welcome message in the beginning, stating that this is a high-low game, the user should pick a number, 10 points, and if it doesn't wait for the user to think of a number before they hit a key, that's 10 points. Okay? And nobody should lose any points on this section of stuff. Right? If you lose points here, it's not because you couldn't figure something out in Bash, it's just that you forgot to do something. Okay, so make sure that you've got those things nailed down. An additional note, I don't want you to use the sleep or clear instruction in your script. Okay, sleep is used to put in a delay, and sometimes after you print a message, it's nice to wait a second for the user to read it before you let them type something in. I'm asking you not to do that. Okay, I want to be able to play the game quickly. I also don't want you to use the clear statement because I want to be able to see the history of the game on the screen. So don't clear in the beginning, don't clear during the game, don't clear at the end. Okay, if you end up doing that, I'm going to take off 10 points. Okay, so that's really easy. Just don't use clear or sleep. All right. So the errors that might more reasonably occur. Remember, you should be able to hit HL or C and not have to hit the Enter key. That's read-n1 variable name. It'll wait for you to hit one button and it'll respond immediately. Okay. So if you don't do that, 5 points. If it accepts something other than HL or C as input, that's 5 points. So make sure they type HL or C. If they type an X, you got to tell them, please enter HL or C, right? And try again. If it exits too early, before it's guessed the number that you're thinking of, or it's detected that you're actually cheating, I should say, or detected cheating, that's 15 points. So if it narrows it down to it must be a number between 41 and 41, you can't say you've cheated yet, right? Until it asks, is it 41? Now if you say that's high or low, that's a cheat, okay? But it's perfectly legitimate to say, oh, high and low are equal to each other. That's okay. So don't tell the user that they're cheating if they're not cheating. Got to put comments throughout your code. Okay, if you're writing functions, you need some comments saying what the function does. Anything that's not totally obvious in your code, put in a comment. Right? When you say guess equals high plus low over 2, why are you doing that? You're going to know why because you've been coding this for 2 weeks and we've been talking about it for 2 weeks. But somebody who hasn't been sitting in this class or hasn't been sitting beside you while you're writing your code doesn't know why you're saying guess equals high plus low over 2. Why are you doing that? Put a comment in. Make a guess in between the 2 ends of possible guesses. If you put H and L backwards, we mentioned this on Friday also, right? When the user says H, it means the guess was too high. When they say L, it means the guess was too low. If you flip those, so H means the guess was too low, that'll be 10 points. If it doesn't do what it's supposed to do when you say H and L, other than having them backwards, if it just does something totally bizarre, right? Like, I couldn't even think of what that might be, but 40 points for that. If it doesn't understand the C button when it's made the correct guess, right? 10 points there. Syntax errors while it's running, 15 points. If it makes the same guess twice in a row, or it doesn't detect cheating. Okay, so test your code. If it says, is the number 41, and you say that's too low, and it says, is the number 41, that's a problem. Right? Chances are you're at a point where it should have detected a cheat. So you want to check that, and I got some test cases down below. If it calls cheating too soon, if you narrow it down to 41 and this says you must be cheating, right, 10 points. If you're using anything other than high plus low over 2 for making your guess, 15 points. Okay, don't just pick a random number in between high and low. Don't pick high minus low or something like that. If it ever guesses a number less than 1 or bigger than the maximum possible number, 5 points. So if you're playing from 1 to 100, it should never guess 0. It should never guess 101. Right, again, it's probably a case where cheating has happened and it hasn't detected it. It's got to report how many guesses it took at the end of the game. Like, it took me 7 guesses. Right, so keep count of each time it makes a guess, print that out at the end. That's 10 points. And it should accept a command line argument to play with a different range. So if I say script 1000, it should play from 1 to 1000. If not, that's 10 points. Those are the main errors that I could think of that might come up. But if you come up with a really original creative error, I might still take off points for it. But I think that's the bulk of it. Does that make sense? And there's nothing here that's not in the original one-page assignment. Okay, I haven't added anything here. I'm just being specific about point values. So again, this can be a checklist, right? Go through and try these. And I put in some test cases to work on. So stuff on the top here is just kind of going back and double checking, right? A good way to make sure that, so the only way to know if I'm a reporter is either you did homework 2 and you haven't changed anything, you didn't like recreate the repo on GitLab or something, or go in and check the settings and make sure under members that I'm listed as a reporter. But a good way to double check this is just go ahead and git clone into a new directory. Right? Go into an empty directory and say git clone, git at gitlab.com, username / uppercase hl.git, and it should pull down your repository, create a subdirectory called uppercase hl that should have the contents of your repo in it. So you can sort of like sanity check to make sure that your code is still over there. Make sure it's called lowercase hl, the script, right? The repo is called uppercase hl. Make sure that there's the first line has been bashed and there's a comment block. Make sure you have comments in your code. Make sure it prints some sort of welcome message and waits for the user to pick a number. And then some numbers that you might try playing with. So pick the number 50 and play your game. Right? And his first guess should be 50 and you say correct, it should say excellent. Took me 1 guess or 1 guesses. And then play a game where you pick the number 1, where you pick the number 100, 299, and then pretend you pick 101 and have it call out cheating. Pretend you pick 0 and have it call out cheating. Pick the number 51, but then when it says 51, say that's too high. And then pick the number 52, but then say 52 is too low. And in those cases, it should very clearly call out cheating. So if I think the number is 51, right? So that's low, this is high, 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 high. Oh, which one did I say? Pick 51, but then say 51 is high. Okay, so if I say 51 is high, it should detect there's a problem there. And then imagine that you pick 52, but say that 52 is too low. So I've got a number in mind. That's too low, that's high, 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 that's too low. And then say 52 is too low, that should throw a cheat. And then play with 1 through 1,000 and try some of those tests. Try hitting things other than HL or C and do that a few times, because sometimes it works the first time and not the second. So try it a few times. And final test, if you're pretty convinced that all of this is perfect, you should be getting 100%, go ahead and just have some other students come to your keyboard and play the game a few times. And maybe they'll think of something that you didn't think of. Or they'll look at it and say, you got your H and L backwards, because sometimes you get so entrenched in something you just see what you think it is instead of what it actually is. So it's nice to have extra eyes on it sometimes. All right, does all that make sense? Yes?
So there was something that kind of confused me on the rubric. It says, yeah, the errors that should never happen. Script is trying to guess user's number. I thought that was the assignment.
Did I mess that up? You're right, yeah.
Okay.
Just trying to guess user's number. Yes. All right, thank you. Okay, so if the script is trying to have the user guess the script's number, that's what we don't want. Okay, cool. You just saved like a bunch of people like some really anxious late nights.
I really think like, oh, I just messed this up.
Okay, so there was one other typo I had in here. Do you remember where it was? It was an of instead of or. Sorry, say again?
It's under the now, the more subtle errors, the first set of parentheses. The of should be the or.
All right. So now this is a perfect rubric, right? I'm going to do this right now, just to make sure. Okay, we good? All right, any other questions, comments? Besides, why did I close Canvas? All right, so let's talk about ODPs. I got a new batch of ODPs posted. So the first one is due tomorrow, so that's ODP 413. Alright, so we're sticking with C, and we're sticking with writing functions, and we're going to start working this week on dealing with strings, arrays of characters. PA4 is going to be really heavy on string processing. So we want to start being able to think about arrays and manipulating arrays where these happen to be arrays of characters with null terminators. So here's your first function. It's called count E, and it takes a character array, a string, and it returns an integer. And it's supposed to go through the string and count how many times it finds a lowercase e in the string. So if you call count E with an argument like hello, it should return a 1. If you give it an argument like E, it should return a 3. And if you call he, ha, e, it should return a 3, and so on. If you give it an argument like ABC, it should return a 0. If you give it an argument like an empty string, it should return a 0. If you give it an argument like hello \n, hello \ne, it should return a 3. Okay, a string is a collection of characters up to but not including a null terminator. Strings are not terminated by new lines. Okay, so count the total number of lowercase e's, return that. That's the integer value that count e returns. So write a test bed, test it out. Once it works, link it in with ODP 413 main.o and assess it. Straightforward. So how do you traverse a string in C? You got a few options as usual. So here's one way, and if you do this, you have to include string.h. Right, because that gives you access to the string length function. What does string length do? It tells you how many characters there are in the string. It counts the number of characters up to but not including the null terminator. General note in this class, when I say character, I don't necessarily mean a letter. I mean anything. Okay, so uppercase letters, lowercase letters, digits, punctuation, spaces, new lines, tabs, all those things are considered characters. Okay, if I mean letter, I'll say letter. So the number of things in the array up to the null terminator. So this is just a for loop, start at 0, go up to that -1, and temp bracket string length -1. Remember, that's the index of the last character in the string. So this will go through every character, and temp bracket I will be the ith character. So you can just say if temp bracket I equals, and for a character E, use single quotes. That's a car. If you use double quotes E, that's a string, which is a car star. Okay, we're trying to compare character to character because this thing, temp bracket I, that's also a car. So if you say is temp bracket I equal to double quote E, it's never going to be equal because it's comparing a character to an address. Okay, so compare it to a single quote E and compare it with equal equal. If you compare it with a single equal, it's actually going to change that value to be a character E, or it'll segfold. And so initialize a counter, tally it up inside your loop, and then just return that counter when you're done. And your test program can be something like it could be a single line. Just printf result equals %d, and for the value to print, just use the return value from count e where you pass it some string. And try it with all the different strings you want to use. Now you can put 10 of these statements in your program if you just want to compile once or whatever. You can get fancier and you can take argv bracket 1 and pass that to the count e function, and now you can test your function with different arguments by just saying, you know, test bed space, put in a different string. That's another option. Okay, the other way that you can traverse a string in C is with a while loop. So initialize some index like I to 0. Then you can say, well, temp bracket I, so the character at position I is not the null terminator. And again, this is a character. right? It's a character equal to ASCII code 0, so that's the null terminator. While this is not the case, check temp bracket I. So do whatever you want with that character, compare it to an E, and so on and so forth. There's other ways, but those are the two most common ways. I like using string length, but they both work equally well.
I think we may talk about this before, but how can I get a string with new line in it? Hello, new line.
So you can say \n, that puts in a new line.
Yeah, I mean, if I use @guys to get the string from keyboard, can I get that new line?
I don't think so. I think if you do \n, it'll be a \n and an n. And if you do enter, that ends the input from fgets. So I don't think you can do this other than at the very end of the string. So if you just type hello, enter, it'll actually end up like that. But I don't think you could do something like hello \n, hello \n using fgets. Yeah.
So, could you also do this by instead updating the memory address and then dereferencing it?
Yeah. So
You'd have to like add four bytes though, right? That's how big a car is. Get to the next car.
I forgot to do I = I + 1 down here, by the way. So you could do temp ++. So ++ is a funny thing in C. This is the one thing that I don't approve of in C, but I didn't get to vote. Which is when you say ++ a pointer, it doesn't always just add 1. It adds whatever the size is of the thing it's pointing to. So for a character, it'll add 1, which is the correct thing. But if this was an array of integers, then temp ++ would actually add 4 to it. It's convenient, but it feels inconsistent to me. So there's a third way you can do it. If you like pointers and you like writing asterisks, just bump up the pointer. Yeah. And it's slightly more efficient than these other ways.
Is it really?
Yeah.
Because you don't need string.h, right?
Yeah, you don't need string.h for that. So do people realize that C was basically supposed to be like assembly language? Right? It's basically a way to write assembly language but still be able to do high-level things like, say high + low /2 to divide by 2. Or have variable names and have it pull those out and do the right thing. But it's really trying to give you access to the CPU on par with what happens at assembly level, right? So you can do things like, say, I want to refer to this memory address, or I want to change what this thing points to by adding something to it. That's part of why so many errors in C aren't errors to the compiler, right? Like, if parentheses I = 0 close paren, which is a single equal instead of a double, that might be something you want to do, right? And you could do that in assembly language, and C lets you do that. It just makes an assignment and then checks to see if the result is considered true. But it's really meant to be, able to sort of stay close to the metal. And so, you find things like device drivers or low-level parts of an operating system still written in C instead of assembly language. Because it translates pretty directly, but it can sometimes turn and bite in unexpected ways. All right, other questions? All right, so we'll stop there for today. Tomorrow we'll start talking more about string processing, and let's keep building this up.